Welcome to a lesson with Dr. Powell. Let's take a look at an application of the idea of variation with a very silly example, which is non-real, but it still should get the point across for what these words mean. Okay, so let's take a look at this. Suppose that speed varies inversely. So speed. I'm going to use R for rate. That's only because maybe I want to use S later for something else. But usually you just pick some letters that help you kind of understand what's going on. So here I'm going to let R be for speed, and it's varying inversely. Okay, so there's some kind of proportionality going on. So I'll just right away write equal to K, some constant of proportionality times something. Since I see an inversely, I know there's going to be something in the denominator. Square root of mass. Maybe I'll use square root of m for mass. All right. And jointly, well, that means things in the numerator, and they're going to be multiplied together as the amount of sugar cookies and the number of sodas. Maybe I'll use C times S for sodas and cookies. Again, this is really silly, and the answer will be bizarre, but let's go for this. All right. So this is in this particular situation, this is the relationship between all the variables. Now, in the end, notice there's a question: how fast will the vehicle be traveling if you have some information? And this information gives us number of cookies, number of sodas, and even the mass, which is again 2,000 pounds right here. Okay, but we can't figure, so if we want to know how fast the vehicle is traveling, we have everything to plug in except for K, notice. But if we look at the information, the situation that happens first, that situation will tell us how to find K. All these problems are pretty much the same. You read them at the beginning, and they tell you how to construct your formula. The next part 2 of the word problem so this is part 1 of the word problem, tells you how to get your formula. Part 2 of the word problem gives you enough information so you can solve for K. So info to solve for K. And then 3, it gives you, it asks you a question that uses that value of K. And that's it. 1, 2, 3. Honestly, these word problems can be tackled in such a way. We just did the first part, was coming up with the formula, which we did right here. The next part right here, let's just plug things in. Suppose the driver is going 65 miles per hour. Okay, that would be the R. And the nice thing about this is that you can use any units you want, because the constant of proportionality swallows all the unit differences up into itself. As long as we keep this constant, we're good with the units. So in these particular cases, units can almost be ignored. Just keep the units the same in each variable as they were in the introduction. But other than that, you just go for it. So 65 is equal to some constant of proportionality. Let's see, the number of cookies, so 2 and 1 soda, all over the square root of 2,000. All right, so that means that the constant of proportionality is, so we multiply by square root of 2,000, 65 times square root of 2,000, all over 2. That's our constant of proportionality right there. Okay, and then we can use that constant to answer the next question. So I'll leave it as a exercise for the viewer to go ahead and actually find the decimal approximation for that. Okay, and actually figure out what the result will be like in the end. So how fast will the vehicle be traveling if the mass remains the same, but the drivers eat 5 cookies and 2 sodas? So here, basically, Well, we have all the information to know R. We want to solve for R. That's the one unknown, but we have everything else. We have the constant, which is right here. We just plug that in. So K times, or actually, no. Oh, it's right here. K, okay. So it's right there. 65 square root of 2000 all over 2. And then we're multiplying, so that's the constant, that's what K is. And then we're multiplying it by a number of cookies. So 5 cookies and 2 soda pops this time, all over square root of 2000. Actually, maybe it was a good idea that we didn't actually solve or do a decimal approximation quite yet, because notice how we get this nice cancellation here. We just basically plugged in C, S, and M as they were in this situation and what the K is, which should be the same in all situations. That's what we're assuming. K is the same always. So notice we get cancel, 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 cancel. So it's just 5 times 65, which is 325. Oh my goodness, 325 miles per hour. Better not eat that many cookies. Okay, and sodas. But anyways, again, unreal, silly situation, yet nonetheless, it drives the point home into how to break up the word problem into 3 different parts. Thanks for watching.